In this video we're going to have a look at subtracting 2D vectors. So we can imagine vectors as journeys on one-way roads. So we've got the vector u here, and we know that we need to travel in this direction along this vector because of the arrow. The arrow tells us the direction that we need to travel. Before we get going, we can just write down what the components of u are. So the journey started here and finished here. So we can write this in component form. I've went along 1, 2, 3, 4, and then I went up 1. So the components of the vector u are 4, 1. If we have a look at this second vector, CD, I need to travel in a downward direction because of this arrow here. And if I wanted to, I could write down the components of CD, because we've went along 1, and then we went down 1, 2, 3, 4, 5. So CD is the vector 1, negative 5. And we can imagine these vectors as one-way roads. We can only travel in one direction. However, if we imagine this in the context of roads, in an emergency, you can ignore the one-way system and drive down the road backwards. Okay, we can go in the opposite direction of the arrow. So if the arrow is going this way, we can go in the opposite direction, but we need to let the people on the road know that we are going in the opposite direction. We need to let the people on the road know that we have reversed down the road. So see if we have a look at this vector u here. So what's the vector u? It's 4, 1. I'm just going to draw it again over here. So I went along 1, 2, 3, 4. Oops. I went along 1, 2, 3, 4 and up 1. So here is the vector u. I'm just trying that using my ruler. So this is the vector u. But see if I wanted to travel in this direction. If I wanted to travel in this direction, well, all I would have to do is I would need to draw my vector u. Once again, I'll do, so it's 1, 2, 3, 4, 1 up. Okay, but see if I wanted to travel in this direction, i.e. if I wanted to start here and finish here, if I wanted to go in this direction, all we do is we say it's the negative of the vector u. Okay, so if we want to find the negative of a vector, that is the road in the opposite direction. We need to make sure we've got the negative there. Okay, the negative there indicates that we're going the wrong way down the road. Let's have a look at the vector CD. What was that? 1, negative 5, wasn't it? I'm going to start here. I'm going to go 1 along and 5 down. 1 along, 1, 2, 3. 1, 2, 3, 4, 5 down. Okay, so here's our vector CD. CD. Okay. So this is the vector CD. But what if I wanted to start at D and go to C? Well, if I wanted to go in that direction, from D to C, well, I would need to switch the arrow's direction, and that would be the negative of CD. So when we go in the other direction, it's the negative of that vector. Okay, it's the negative of that vector because that allows us to then draw it, and that will help us to draw it and look at the components of it. Okay, so what have we got here? In this first example, draw a diagram to illustrate u minus v. Okay, let's have a look at what we've got here. We've got a vector u and a vector v. So if I want to draw a diagram to illustrate u minus v, what I'm going to need to do is I'm going to need to take the vector u and I'm going to need to attach the vector that is negative v onto the end of vector u. Okay, so I want to draw the diagram u minus v. So I've got my vector u, that's okay, but I don't have the vector minus v. So I'm going to need to draw that first. So here's the vector v. What is that? That's 3 minus 1. So if we draw there we go. So if we want to draw minus v, well, it's going to need to go in the opposite direction, and that is the vector minus v. Okay, so I've now got a vector for u. I now have a vector for minus v. That's maybe a tick. Okay, so I now want to draw this. So what I'm going to do is I'm going to take my vector u, and I'm going to attach my vector minus v onto the end of it. Okay, so let's have a look. What is the components of u actually? So the components of u are, what is it? It's minus 2, it's 2 to the left, and then 1, 2, 3, 4, 5, 6. So the components of u are minus 2, minus 6. So I'm going to draw u first. I'm going to go 2 to the left and 6 down. 1, 2, 3, 4, 5, 6. Okay, so here is my vector u. Okay, and then I want to attach vector minus v onto the end of vector u. Okay, so I'm going to put minus v onto the end of u. So minus v, the vector minus v, this vector here, it was 1, 2, so it's 3 to the left and then 1 up. Minus v was a vector 3 to the left, 1 up. So let's do that from the end of u. So we're going to go 3 to the left and 1 up. To move this, there we go. And this here is the vector minus v. So my journey has started here, and it has, and it has finished here. So hopefully you can see the vector u minus v is this line in red here. We've went in this direction, and that is u minus v. Okay, so that's us done part A, where we've drawn the diagram to illustrate u minus v. U minus v is this red vector here. Okay, so it then says for part 2, state the components of the resultant vector. So I want to write down the resultant vector in component form, so u minus v, i.e. what is the vector in component form of that red line. So let's have a look. So for this resultant vector here, if I highlight it, well, I have went 1, 2, 3, 4, 5 to the left, so that's going to be minus 5, then I've went down 1, 2, 3, 4, 5. So that's minus 5, minus 5. And then it says, and calculate its magnitude, leaving your answer as a simplified surd. Well, to calculate the magnitude of a vector, remember we put the bars around it. So we want to work out the magnitude of u minus v. So we're going to take minus 5 squared. Okay, this is just Pythagoras here. So that's 25 plus 25, which is the square root of 50. And we can simplify this surd as root 25 root 2, which is 5 root 2. Okay, so here we've just drawn a diagram of the vector u minus v. We've stated what its components are, and we have then worked out the length of that vector. Just to recap here, we could have just done this in component form, just to double check. So at the side here, we said that u is minus 2 minus 6. Excuse me, sorry. There we go. If we have a look at this vector v here, so that vector v was 3 minus 1. So if I wanted to figure out u minus v, well, I could take my vector u and subtract the components of vector v. 2 minus 3 is minus 5. Minus 6 minus 1 is minus 6 plus 1, which is also minus 5. Okay, so that's a way for us to check as well. So we can do it with diagrams, and we can also check just using the components here. Okay, that's example 1. One final example, we'll go through this a wee bit quicker. So draw a diagram to illustrate a minus b for the vectors a and b. So the vector a is 3, 4. So I'm just going to start here. Okay, so we're going to go 3 along and 4 up. 1, 2, 3, 1, 2, 3, 4. Okay, so here is our vector A. Three along, 4 up. B is 2 minus 5. Pick a point here. So we're going to go 2 along and 5 down. 1, 2, 3, 4, 5. Okay, there's the vector B. Okay, what we want to do is we want to state the components of the resultant vector and calculate its magnitude to 1 decimal place. So I want to draw A, and then I want to attach negative B onto the end of it. Okay, so negative B is going to be this vector here, but going in the opposite direction. Okay, something like this. So here is negative b. Okay, so I want to draw A followed by minus B. So I'm going to draw A, which is 3, 4. I'm going to draw this down here. So where's A? We'll start here. 1, 2, 3, 1, 2, 3, 4. So here's vector A. And I want to attach the vector minus B onto the end of it. So minus B, what was that? 2 to the left and 5 up. So from this point here, we're going to go 2 to the left and 5 up. 1, 2, 3, 4, 5. And this here is the vector minus B. So the vector A minus B is the journey from the start to the finish. So this is the vector A minus B. Let's state the components of A minus B. A minus B. So we started here. We started here. And we finished here. So we went 1 to the right, and then 1, 2, 3, 4, 5, 6, 7, 8, 9. So A minus B is the vector 1, 9. We then wanted to calculate the magnitude of A minus B. So that's going to be the square root of 1 squared plus 9 squared. That's going to be the square root of 82. And if we have a look at the square root of 82, you can either leave that as a third or put it in your calculator. That was going to be 9.1 units. Okay. Remember as well, we could have checked our answer here using our vectors at the top. A minus B, if we have a look here. A was 3, 4, B was 2 minus 5. So we've got 3, 4, subtract 2 minus 5. That's going to be 1. 4 minus 5 is 9. 1 minus 1, 9. And we can see I've got the same answer in a diagram as we do in the component part. Okay, hope that was helpful and you can get going with today's work. Thanks very much.